The Yolo model from Ultralytics has been very effective, not only from the point of view of the model's performance, but also from the point of view of the ease of deployment. So in this video, I'm going to go over the code and some basic steps in order to get a Yolo model from Ultralytics up and running. Welcome back to the channel, guys. My name is Dhruv and I'm here to talk about advancements in computer vision, to share my knowledge and to gain knowledge about computer vision. And in this video, I am going to specifically talk about working with the Yolo model from Ultralytics. I'm going to show you a live tutorial, and hopefully by the end of the video, you know how to get a model and train a Yolo model using the Ultralytics framework, and you're able to create your own object detection, classification, or whatever work that you're trying to do, a demo for that. Guys, if you want to get in touch with us, here is our contact information. You can call us, email us, WhatsApp us, and we would be happy to assist you. First of all, guys, in order to get started with the Ultralytics Yolo, the most important resource that would be very helpful for you will be this quick start guide in Ultralytics docs. So this guide over here has information about how you can install this library, and it also tells you about installing Torch. So you need to install Ultralytics, and you would also need Torch. Torch, for those of you who don't know, is an automatic differentiation library. A lot of deep learning systems either use Torch, TensorFlow. These are the most popular libraries out there, and Torch is developed by Facebook, and it's kind of open source, so a lot of companies use Torch for their deep learning development. Now, essentially, the way I'm going to go over this tutorial, I'm going to use Google Colab for this. And if you are not familiar, Google Colab is Google's environment. It's like Jupyter Notebook. You can create a notebook, and it's very easy to do prototyping and some additional initial testing, model development in Google Colab. So here is what it looks like. You can create a new notebook. Here you can see I've already created the Yolo Ultralytics IPython notebook. So here is that, and the first thing I tried was just to see if Torch was installed. So when I run this command, it runs, which means Torch is installed. Then I had to install pip install the Ultralytics to install Ultralytics, and once that is installed, here you can see the requirement is satisfied for that. Then we go to importing Ultralytics Yolo. Once that is done, here we are creating a model. So now what we're doing is we're telling Yolo, instantiating a Yolo model, and we're giving this config file for Yolo v8. So we're telling it to create a Yolo v8 model. Once you run this, here you'll see here you can print out the entire model. So here is what the model looks like. The entire architecture for the model can be seen here, including the convolutional layers, the batch norms, the activation layer, everything. So if you're interested in knowing the details of the model, you can go through this and you would be able to understand what the model is made of, what the architecture is. Now that you have the model, here we load the pre-trained weights for the Yolo model. Now, why do we load pre-trained weights? Because it's just when you are trying to train a model from scratch, it just requires a humongous amount of data, and it becomes a very hard process to train. Instead, what you can do is you can use a pre-trained model. So you have a model with pre-trained weights, which, for example, here we have loaded pre-trained weights into the model. That way, the model already has learned some basic, most important features. You can fine-tune it on your specific data, and that way you would not need a lot of data and a lot of training in order to get good performance. In this line, what we're doing is basically training the model for 3 epochs using the Coco 8 configuration file. So when you run this training, because it's just 3 epochs, it will not take very long over here. And here it's basically getting the training set, the validation set. This is the optimizer. Atom is being used here with the momentum. And this over here, now we're seeing that the training is progressing. The first epoch is done, second is also done, and the third is on its way. And third is also done. Now once this training is complete, then we can evaluate the performance of the model. Essentially here's where all the training outputs are saved. So you can see the results saved to detect train 4, and this is basically train 4. Here you can see all the specific classes on which the data was trained. Then we have the results. If you look at the results, it shows the curves for train loss, validation loss. Because we just ran it for 3 epochs, you see this pointy curves, but if you run it for say 100 epochs, then you'll see a trend where train loss should go down over time. Now that we're done, here we run the validation. This is just going to evaluate on the validation set, and we have a validation set over here. In here, this is the validation set. So now the model is running on this, and once the validation is done, the results are saved in here as well, over here, and we can basically see this is the validation labels on the validation set. So you see the labels, and then these are the predictions. Here are the labels. This is a dog. You can see horses, potted plant, person, umbrella, and then we have the predictions where it has detected the person but not the elephants. It has detected dog, it has detected person here, it has detected umbrella and person both here. So this is just a simple example for the validation. Let's try to run it on a sample image. So here is an image of a bus with people in front of it. Let's see what it's able to do here. So I run it. The inference is done. Let's look at the results. So this is going to save the result to the result JPEG, and let's see. It has detected person, a bus, and a stop sign. Probably this is not a stop sign, but it's highly occluded, and it has detected some sort of sign and labeled it as stop sign. But still, nevertheless, it's able to detect, and even it has detected this person, which is highly occluded. Here, this person on the left, which is good. Right now, I tried another image from the internet. I just got this image, like with some traffic, and I tried this model. So let's run this. The inference is done, and now the result will be saved. So let's see the result. Here you can see it has detected a person, it has detected all these cars, and it has detected traffic light. So far. And again, it has never seen this image in the training set, right? So I just loaded the pre-trained model, and I'm running this, and it's able to do all of that. So again, this shows how powerful this model is. In case you're looking to run a model on any of your tasks, this is a great place to start. And I hope with this video you're able to get some understanding. This model, this initial code, you can find it in the quick start guide over here. We'll also put it on our Convolve AI's GitHub channel. The link will be in the description. It would be uploaded to our GitHub page. So that's it for today's video, guys. I hope this video helped you understand how you can use the Yolo model from Ultralytics. Again, it's pretty simple, and it's a great tool if you are interested in running object detection or any kind of computer vision models on any of the tasks that you're trying to accomplish, be it at work, be it for a school project, or be it for your own freelance projects. Thanks a lot for watching, guys. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. We try to upload 2 videos every week with latest and greatest updates in the field of AI and computer vision. So stay tuned. Thanks a lot for watching, and I'll see you in the next video.